Okay, now we're going to do lesson 5.4, which is using experimental probability to make predictions. So, scientists study data to make predictions. You can use probabilities to make predictions in your daily life. Danae found that the experimental probability of her making a bullseye when throwing darts is 2 out of 10 or 20%. Out of 75 throws, about how many bullseyes could she predict she could make? So, first thing we could do is we could make a proportion. If she makes 2 out of 10, they want to know how many she would make out of 75. So then we would multiply the bottom by 7.5, and then when we multiply our denominators by 7.5, we also have to multiply our numerators by 7.5. So 2 times 7.5 is 15. The other way that you could do this, if you didn't see to multiply by 7.5, is that you could cross multiply 2 times 75 and then divide that answer by 10. You should still get 15. If you don't, there's something wrong. The other way that you could do it, and what a lot of people find the easier way, is that you could use a percent. So we change our 20% to a decimal, which is 0.2, and then multiply that by 75, and then we still end up getting 15. So Danae can predict that she will make about 15 bullseyes out of every 75, which is much more than I would make. I would probably make 1, maybe, if that. So pause the video and try the Your Turn question on your own. It says, a rental car company sells accident insurance to 24% of its customers. Out of 550 customers, about how many customers are predicted to purchase insurance? So use one of these two methods and answer the question. When you come back, check your answer against mine. So, whenever you set this up, either as a proportion or you use the percent method, you should get 132. If you do not, then you need to go back and check your math. Maybe you made a simple calculation error, or if you set up your proportion, maybe you set it up incorrectly. So, if you need help, make sure you let me know. Turn the page. So, we're going to use experimental probability now to make a qualitative prediction. If you don't remember qualitative and quantitative, you're going to have to go back to the very beginning of Chapter 5 in order to figure out what those two words mean. So, a prediction is something you reasonably expect to happen in the future. A qualitative prediction helps you decide which situation is more likely in general. So, example 2. A doctor's office records data and concludes that, on average, 11% of patients call to reschedule their appointments per week. The office manager predicts that 23 appointments will be rescheduled out of 240 total appointments during next week. Explain whether the prediction is reasonable. So, just like before, you could set up a proportion. 11% is 11 out of 100. So if we have 11 out of 100 reschedule, how many out of 240 would reschedule? So then we multiply our denominators by 2.4, and then we multiply our numerators by 2.4. Remember, you can always cross-multiply. You should end up getting 26.4 patients. The other way is to use your percents. So we would change 11% to a decimal, which is 0.11, and multiply it by 240, and it still gives you 26.4. So her prediction is reasonable at 23, but it's a little bit low because he should really have about 26.4. So, pause the video, do your reflect number 2, which is, does 26.4 make sense for the number of patients, and explain your answer. When you come back, my explanation will be here to check yours against. All right. Does 26.4 make sense for the number of patients? Explain. No, not really, because can you have 0.4 of a person? Anytime you're dealing with people or animals, you really need to work with whole numbers because, once again, you can't have 0.4 of a person. So you would need to round your answer. This one you would round down to 26. For the number 3 on your turn, it says, in emails to monthly readers of a newsletter, 3% of emails came back undelivered. The editor predicts that if he sends out 12,372 emails, he will receive 437 notices for undelivered mail. Do you agree with his prediction? Well, hopefully you worked it out before you just cheated and looked at mine, because that's not going to help you any. But no, 371 undelivered out of 12,372 is a little bit too high. When you work it out, you should get a number less than that. If you would like me to check your number, let me know. I will be more than happy to do so. But this is just a little bit too high. Last page. Okay, we're going to make a quantitative prediction here. It says you can use proportional reasoning to make quantitative predictions and compare options in real-world situations. So, an online poll for a movie site shows its polling results for a new movie. If newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on the online poll? Is the movie site's claim accurate? If the newspaper finds that 104 people say they like the movie. So, the answer is a prediction based on how many people out of 150 will like the movie based on this online poll. Also, tell whether 140 people can say they like the movie is enough to support the movie site's claim. So what we need to do is we need to list our important information. The online poll says 72% of moviegoers like the new movie, and the newspaper surveyed 150 people. So we're going to use a proportion to calculate 72% of 150 people. So percent again means out of 100. So if 72 out of every 100 like the movie, how many can we expect out of 150? Well, 150 is bigger than 140, so we should expect logically to have more than 72. So when we work on our proportion, we do 100 times 1.5 to give us 150. So when we multiply our denominators by 1.5, we have to multiply our numerators by 1.5, and 72 times 1.5 is 108. So your newspaper can predict that 104 out of 150 people will say they like the movie based on the online poll. So now we need to evaluate our answer. Since 108 is close to 104, the newspaper survey and the online poll show about the same percent of people liking the movie. So this is a pretty good claim. So what you need to do now is pause the video and do the Your Turn number 4. Whenever you come back, my answer will be up and we can compare. If you need some help, be sure to let me know or to request a workshop. So, on average, 24% of customers who buy shoes in a particular store buy 2 or more pairs. One weekend, 350 customers purchase shoes. How can you predict to buy 2? How many can be predicted to buy 2 or more pairs? If 107 customers buy more than 2 pairs, did more customers than normal buy 2 or more pairs? I feel like I just said 2 or more pairs a whole lot. So you may need to replay this or reread it on your own in order to set up the correct proportions. So I predicted that 84 customers. So yes, 107 is greater than 84. So more customers than normal bought 2 or more pairs of shoes. So if you did not get that or something similar to it, definitely should get 84. Then you need to go back and check your work and maybe go back and review the section if you need any extra help. So at this point, the video is going to stop. You need to complete the guided practice and then come back and check your work. If you don't get these right, you need to be rewatching the video, rechecking your notes, and then possibly requesting a workshop if you're having difficulties. You have to make sure that you let me know. Good luck.